Okay, so a couple of things came up the other day that really made me think, okay, these are good examples of the point of what I'm doing with the everyday Maya. And the idea is that when I'm working in Maya, is that, maybe I'll script something, maybe I'll create something from scratch, or maybe I'll just do whatever. It's just, you never know how you're going to work that day or while you're working. And these are just things that I do every day using Maya. So this one was kind of interesting because I was like, okay, there's a whole lot of things I could explain here. And it was with dealing with motion paths and also dealing with how to sort of circumvent how they're created and also to sort of script up something, but also see what exactly Maya is doing. So it's deconstructing what Maya does by default and then also using that to your advantage. So the idea here is that everything you're doing in the menus, you can almost think of it as like a macro, and everything that it's doing is creating something, with nodes. So Maya is just lots of nodes connected to other nodes, right? So if you take something and you key it, and you open up the NodeEditor, what you see is, your transform object here, and then you have all these which are actually animation nodes connected to that transform object to tell it what to do. And all the nodes have special abilities and they can do whatever they do. If you hit 5, it'll actually show you the node type. So you can see it says transform for my P-cube1. And then these are all the different types of animation nodes that are going in, which sometimes makes it a little confusing. But if you look, you'll see that all the ones going into translate, if I can find them, there we go. Translate, and TL, where's the TL? Okay, so these are all time to linear, I believe that's what it's called. And then you have time to unit for, looks like that's all going into scale and visibility, and also time to unit going into, oh, look at that, time to arc, maybe? I'd have to look it up, I'm not 100% sure. But either way, you hit 5, it'll tell you the node type. That comes in very handy. But what I'm getting at is that these are all just nodes connected to nodes that create what your animation is. So in this particular instance, they were talking about using path animation. So under constraint now, motion paths attached to path. You get this, and they're like, okay, I don't like that. It creates. And this is something that I haven't really delved into, but I found it interesting. It creates all these add double linear nodes. And I think what they're doing is, what is it using? Something to do with the pivots. Doing something with the pivots and going in, but what the gist of it is that this isn't actually necessary and just adds extra nodes, and sometimes we'll create those cycle checks that you see. And they're like, I don't want those cycle checks, and I want a cleaner thing. So, of course you can go in there and just change your connections, but they wanted to do it like for 100 things. Okay, so the first thing to do is to get rid of these add double linears. And for that, it's pretty easy. You're just doing your direct connections between the two and then taking these and cutting them. And if you watch, it all still works. Front twist still works, up twist still works, side twist still works. I'm guessing, yeah, I don't know what, I guess it was a weird pivot thing. Maybe when you move the pivot, it tries to keep it on. I don't know. In any case, not important. But the important thing was just to deconstruct what Maya is doing and then recreate it and then make it so you could do it over and over and over again. So the easiest way to do that is obviously with a script. Now, when you do create path animation, Maya runs a script. Let's see if I can find it. I might just have to redo it. I'll just delete this cube, create a new one, and do a path animation. Do I have echo on? You don't have to have echo all commands on. In fact, in this case, it just makes it harder to find. But if I go up here, I'll find it. There we go. So the command that it uses is called path animation node, and this is actually a macro as well. it's already got a bunch of flags and inputs into it that do a bunch of things automatically. And you see here, what this is here is it's getting the min and max time for the start time u and end time u. So it's even running a script to get that information, or a command I should say, to start and end time. So we don't really want any of this, because what it's going to do is still put in those add double linears, which were causing some of the problems to begin with, right? So instead of doing the path animation code, create it, I'm just going to create this using the create node command. So though Maya has a command called the create node command, which basically just it creates nodes. So if you're doing shaders and things like that, this is often what I'll use. I'm just going to, hopefully my last Python channel, tab I should say, sorry, I have hundreds of them. Come on, and we'll use whatever this one is. Okay, actually, you know what? Yeah, that's fine. So what I'm going to do is recreate this. So the first thing I want to do is create that motion path. So that's just the create node. And instantly, if you have command completion turned on, it's just Control Shift will complete that command. So if you right click, I have the menus turned off, but I just right click here and say command completion. There's also object path completion. I might turn that on for this and see what I get. But what's cool is I type in commands and then the dot, and it gives me dot end. Oh, that's interesting. I wonder why I did that. It gives me a whole bunch of things. So if I start writing create and hit that, it's going to give me all the things that start with create. And I can just continue typing from there, hit it again, and get that create node, right? Wow, that's interesting. I'm going to turn off object path creation because it seems to be giving me errors. I've not seen that before. I never used that. But anyway, and the node I want to create is a motion path node. And if I hit that 5 again in here, you see motion path, right? And it's kind of all I need to do to create that. But I do want to capture it in a variable. So I'll call it mopath, right? So now when I run that, I get a mopath, right? And it's the same thing as if I hit tab and say motion path. There's my motion path. And you want to make sure that it shows up and it has what you want on it. Because if you do misspell this, it will create a dummy node. So I do commands, create node, blah, blah, blah. Give me an OSDA node. Those are the best. It actually will still create a node, but it'll call it unknown. So that's when you know you have a typo or something like that, just in case. Okay, so what I'm going to first look at is the curve going in here. So I'm just going to hard code in our curve 1, and I'll change that later, but for now I'm going to say curve equals, not that, that was interesting, curve 1. And you notice that my variable, I'm using something that's not really a word. The reason for that is I don't want to use anything that could potentially be an already used variable. Python will actually redeclare variables as you're using it, which is very powerful, but also could be very dangerous. You can overwrite things that already exist. So if you do like ls equals something, you might overwrite what ls means, and then it won't work anymore. All right, but if I create that, I now have a variable that stores that information. And then, oops, not mop path, but mo path. And if I look up here and hit 2, I can see that the world space is getting connected to the geometry path. Now, recently they added under your options, under display attribute names, long names. By default, it's set to nice. And I don't really like that because when I look at this, I see it says geometry path with capitals and spaces. And you know, in this case, I could probably decipher what it is, but I don't really know what that exact spelling is. And if you look at the one like u value, it's got a capital U and a capital value, right? So you think, oh, it's probably u value, except that it's, you know, in reality, it's lowercase u and then value. Over here, I also have long names. I always use long names because I want to know what those names are. I don't like the aliases and the nice names and things like that. So one way I could get that information back in the day, or still anyway, is if I use Shift and Alt, I can actually cut that connection and undo it, and it actually gives me back what that information was. And it's a good way to get that code really fast. But I still like turning on long names so I can read them and see what I have, right? So I know I want my nerves curve shape going into my motion path geometry path. So right now I only have the curve itself. So I want to get its child or shape node. So to do that, I'm going to use, let's say curve shape equals, I'm going to use the command list relatives. Now, list relatives is just for getting your parents or your children. I don't think it'll get siblings. I think you got to go up and over to do that. I've actually never really had to try that. But I'll give it the curve variable that we've created. And then I know I want shapes. So I'll set that input as shapes equals true. And I know I want children. Because you can also, otherwise, if there's any parents, it'll get the parents. I'll set that to true. And the last thing I'm going to do, and I'm not going to type this one out, but I'll just use the shorthand, which is ni equals true. And that means no intermediates. And basically what an intermediate is anytime you apply a deformer to something, let's say we'll put a cluster on here, and I'll move it over just a little bit. This curve now has 2 shape nodes underneath it. So if I add it here, you'll see that. And if I hit 5, you're not sure which one's which, but I'll hit 5 again so we can see what they're called. And what it does is it takes your original shape and calls it, renames it to orig. If it's not a reference, it'll do that. Here's my transform node. And then it creates a new one. And then what it does is its deformer information in between here to get your end result. So a way to see what your orig nodes are is you can actually select that orig node. I'm going to go to the attribute editor, and under object display, this tag here for intermediate object. So if I grab the one that's visible, you'll see intermediate object is not turned on. If I select the orig, you'll see it is turned on. But I can actually turn it off so I can see both at the same time, which can be a little bit confusing. But basically what that does is it uses that orig node to tell it where, how to deform this object. And what's interesting is I can go into that orig node, which one is it? It's that one, and change it, and it'll still change downstream. Probably would never do that, but just so you know, you can if necessary. And you'll also notice if I do a selection, I end up getting both of them because I have 2 visible shape nodes underneath. So I always throw that ni flag in there because what that's going to do is ignore that extra shape node. So if I run this right now, and then I highlight and run curve shape to see what I've got, you'll see that I have a list. That's why the brackets are there. And I have curve shape 1 and curve shape 1 orig, because I'm actually showing that one at the moment. Because the only way it knows is if that's checked on, right? So what I'm going to do is go back in and recheck this on, because that would be default behavior. And I'll run it again. And you see I still have a list, but I only have one object in it, which is that curve shape. And if you ever want to know what a variable is in Python, you can always type in type, and then in parens put the variable, right? So what's cool about lists in Python, and actually, well, in all programming languages, is you can then go in there and get that information using numbers. So the 0 would be the first object, 1 would be the second object, 2 would be this third object if there is one, right? So if I go back in here and turn this on again, run this, and I say curve shape 1, because remember, one thing to know is that these arrays are always going to start at 0. So if I type in 1, I'm actually getting the second in the list, which is the orig. If I type in 0, I'm taking the first in the list. So one thing that you can do that's kind of cool in Python, you can't do this in Mel, is actually I can say, you know what, run this, but only give me the first object. So let me run that, and you see now I get back well, I'll do it again, type. Sorry, I should have left that. Curve shape. Oh, CRV. Hit my own bug. Okay, cool. Cool, I get Unicode, which is basically a string variable. So it's no longer an array variable or a list like it was before. Sorry, in Mel it's called an array. In Maya it's called, or in Python it's called a list. Let me just pause one second. So now I'm getting back, whoops. There we go. Now I'm getting back just that one object, which is what I want. And I can make that connection. So if we go back over here to our, remember this is just a dirty scene, so we don't care about recreating it or whatever. So now what I can do is take that NURBS curve shape, its world space 0, and put it into geometry path. So I'm going to do that trick again where I cut it. I'm going to go in here. And this is kind of the nice thing about Maya is that it prints out a lot of information in the script editor. I don't have echo all commands on. This is just standard behavior. And I'm going to say use a connect adder command. So connect adder is basically what you're doing. You're saying create these nodes, connect them together. That's 90% of what Maya's ever doing, right? Just make some nodes and connect them together. So actually, I'm just going to grab this whole thing, put it there. But I do want to change what these are a little bit so that they use my variables instead of using the hard-coded path or hard-coded names. So for this first one, for curve shape, I'm going to change that to my variable curve shape plus. And often what I'll do is actually separate out that period that denotes that it's a channel, only because I find it easier. I could just copy and then only put that part in there. I know it sounds a little bit weird, but maybe down the line you'll see what I mean. And then my MoPath is going to be the second object, and it's getting connected to geometry path. And the nice thing about that is it's doing it all for me. I don't, since I did it this way and copied and pasted, I don't actually have to type that much, which is kind of nice. So let's clear this, run this. Here's my motion path, and we'll see that there's that curve 1. It's connected to my motion path. Right. Oh, and incidentally, if I go in here into this cluster and delete it, it will pop back to where it was. However, let's see if it did it or it didn't do it. Yeah, I still have that orig node, so those guys can get left behind. There are a lot of ways to delete them. One of them is using, where is it, optimize scene size. I think it's edit. I do it with code, but you can also do center file. Yeah, optimize scene size. So you can actually go in here and run the unused deformers. That's for another tutorial. Okay, so I've got my curve connected. It's good to go. Got my motion path. What's next? So go back to here. There's a little recipe that we have sitting here. And it looks like there's nothing else we need to go into the motion path. If we wanted a curve, we could do that, but we don't need a curve for this. I'm going to do that a different way. But I do need to go to an object. So generally speaking, when I'm writing a script that I'm going to use for something, it's almost always acting on selected objects. So what I'm going to do for that, and I'm sure if you've done any scripting or seen any scripting, you've seen this or something like it. And basically, the ls command is just the list commands. The sl is saying what's selected. So give me a list of what's selected. Right now, there's nothing. So let me add a cube to the scene. I'll run this. And again, it's going to give me back a list. There's those brackets again. Make this bigger. Cool. So there's those brackets again to tell me I have a list. And that's okay, because what I want to do is work on a whole bunch of these objects. So then what I'm going to do down here, let's see, we've created a mode path, created a curve. Okay, so what I'm going to do is create a simple for loop. And that's going to iterate through all the objects I have selected. Right now it's only one. That's okay. So I'm going to say for each one, each in cell. Wow, spelling is not working. And I want to take this information and tab it over. So this little guy right here is going to tell Python that I'm now in a new scope. Scoping, I don't know if I can get into it right now, but basically it's just an encapsulated part of code that gets run and doesn't get run outside itself. So this little loop is going to run inside itself. So it's saying for each object that is in the selection list, that's this list, do something, right? So right now it's going to create a motion path and then connect the curve to that motion path. But I also want to connect that motion path to each object. So what's kind of neat is, like, say I have a whole bunch of these cubes and I run a cell on that, or my commands.cell. Basically it's going to say, it's going to convert these guys to each every time that it gets run. So it's just a way to store a variable. So now I can just use that variable down here and say commands, connect adder. I'm going to use my MoPath, and for that I'll just copy this part here. And what I'm going out with, let's do rotate because that's the easier one. Let me make that bigger. I have a whole lot of nodes here, so let's get rid of these and bring them back so it's clean again. Cool. And rotate's fairly easy because it's rotate X to rotate X, right? And rotate Y to rotate Y. But what I'm going to do is I'll make a little loop inside this loop to make my life a little bit easier. And so I'll go up here and create a new list. And that list is just going to be XYZ, which is very simple. I'll call it axis equals brackets X, Y, Z. Whoops, Z. There we go. And what I can do is I can say for AX in axis, so for X, for Y, for Z, do something. So I'm going to say connect MoPath.rotate plus AX to, and actually in this case I'm going to copy this and just change MoPath to each. And so now what it's going to do is say connect rotate X to rotate X, and then do it again, but this time for Y, connect Y to Y, X to X, Z to Z, and so on and so forth, which is pretty cool. We do have some extra special things. I'll get to this one next, but yeah, sure, I'll just do that now. So I'm also going to grab this again, and I'm going to run this, and this time I'm going to do the X coordinate to the translate X. So I'll start with this because it's easier. Translate, right? However, the X coordinate, you'll note that the X is lowercase. So I have to do something a little bit different here. So I'll do, make sure I spell it right. Capital coordinate. Yep. Coordinate. Yeah, okay. For this, I'm going to use something special in Python, which is really cool, which is formatting inside strings. So I'm going to use curly braces here. It's a little deep dive, but, and when I do that, I can insert something into my code, into my string variable here, or my string that I'm creating. And the format is just to take whatever inside here, run it, and make it into a string and put it here. And you can use a bunch of curly braces in there, which is pretty cool. So you could have a whole bunch if you wanted, but in this case, I only need the one. But I don't want capital X, I want lowercase x. X. So there's a cool command in Python, not loser, wow, I did it again, called lower. And basically what it's going to do is take whatever string it is and just make it all lowercase. So as an example, I'll just say foo equals, whoops, something like that. And I'll say foo dot, and this is a Pythonic object. When you hear object-oriented commands, this is what that means. The string actually has, as an object, right, in Python, has commands that it can be, that it automatically can do. And one of them is lower. So when I run that, it actually gives me everything back in lowercase, even though the original is still there. So it's only temporary, and it does that, right? So what I've now done is converted it to lower, put it here, move this over, and then connected to translate X. Cool. And then lastly, I have message going into specified manip location, Jesus, and I have rotate order to rotate order. Well, rotate order to rotate order is easy, so I'll grab this. It's a single one, so I'll put it above, and I'll say rotate order, get rid of the AX, and do the same thing here. That's pretty easy. Oh, path message is to specified manipulation. So I'm just going to use my cut trick, cut and undo. There we go. Makes it a little bit easier. All right, so I'm going to make a new scene here. Wait, is there anything I missed? No, I don't think so. All right, so I'll make a new scene. Just in case, I'm going to grab this, copy it, and stick it in Notepad. I don't want to crash or anything. Unless you save preferences, whatever's in your script editor is vulnerable to crashes. So if I crash, I might lose everything. So be careful when you're doing this, any sort of scripting in there. It depends on how much you care about what you're scripting and how easily recreatable it is. All right, so what I'm going to do is, what am I going to do? I'm going to make a curve. Cool, and I'll make some cubes. All right, bring my script editor back. I'll select those cubes. Since curves, when you create them, it's always curve 1. I can just leave it as that. I'll select this, highlight this, and run it, and hope that it works. And it did. Super cool. Great. So if I go in here and grab any of these cubes, you see they have a motion path. If I graph that motion path, you see it looks like this. If I graph the curve shape, this is kind of neat. You see here all my cubes that I've created. Here's my curve shape, and here's all the motion paths that I created. Now the one thing you'll notice is nothing happens, right? Because we are just creating that node. We're not doing any animation to it. We're not setting any variables. We're not setting any values on the motion path. They still have those values on them, right? I can move them. If I select them, right? If I select all of them, I can get all their motion paths and move them all together. You know, if I need to get access to it. But it hasn't created any animation on it. It's a default node. Basically just however the defaults are set for it to be created, and we find that out as we work, right? Okay, so what I want to do is space these guys out a little bit better. So let me undo. Come on, there we go, cool. And I'll run a flush undo just so I can get rid of some memory. Okay, so what I want to do is move these guys along that path by default. So what I'm going to do is kind of a cool thing that I like, which is called enumerate. So I'm going to say for I, comma, each in enumerate cell. And what enumerate is going to do is it's going to go through each object in here like a for loop, but it's going to kick back two things. It's going to kick back a number, and it's going to kick back the name of the item that you have. I don't think I can run it like this. No, I don't think so. Cool. It's a function, so basically, but it's going to kick back. So what I'm doing is I'm capturing the number and capturing the item, right? So if I go in here to my motion path and I say commands.set adder mopath plus u value. So I like using the long names, so I've already gotten rid of it, but you saw that it was there. And to put that, so I'm combining this string and then giving it a value. In this case, it's going to be I. So it's basically this I is going to go 0, 1, 2, 3, 4, and all the way through. Right? So if I select all these guys and run my command, I get all my cubes all laid out all along my my curve here. But you notice they're not exactly spaced out as you'd expect. I'm going to copy this so I don't lose it, just in case. All right, so this is something that's you also should know about motion paths. So right now, our motion paths are in their default. So if I look at them, what's a good way to show this? Let's take a look at this. So first off, you'll see that I have a whole bunch of cubes. Where's 11, 12, and 13? That's interesting too. So I have a whole bunch of cubes that are at the end of my curve here. And the reason for that is by default, with no options set, motion paths have this thing called parametric length turned on. And what that's going to do is look at the actual U values of your curve. So when you create a curve, you have a min and max parametric value. So it's based on the number of spans. So I have 10 spans, so I have a parametric value of 0 to 10 by default. If I were to rebuild this curve, but do it in such a way that it was to be 0 to 1, watch what happens. Everything goes to the end. And the reason for that is because it's now, this is 0 and this is 1, whereas before this was 0 and this was 11. So think 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the default creation of curves is always going to be to the number of spans, and the default, if you're not using, the command here or the path command, is going to be setting the motion path to parametric length. And so basically that just means use the parametric length. If I turn that off, well, let's see, which one was that? This one? All right, let's hide all the others so I don't get lost here. Cool. I'll turn parametric length off. I'll grab this cube. And basically what parametric length is just says this is now 0 and this is 1. So it makes it normalizes the curve. So it's a nice even spacing around the whole thing. So you'll watch if I go in here and do a nice slow drag, it's nice even spacing along that curve. Because the spacing on my curve may not necessarily, look how close these 2 points are, or spans, versus these two. Sorry, these two here. So if I go back to that curve, that motion path, turn parametric back on, and now I'll try and do a nice, for one's a lot slower because I have a lot bigger numbers to go through. But see, I don't know if you can tell, because if you're not doing it, it's very hard to tell. It speeds up quite a bit between here and here. So between 9, look at that, and 10 is this much of a gap, whereas between 2 and 3 is this much spacing. So if you have an even linear curve, it's going to go slow through here, fast through there. That may be something you want, maybe something you don't want. The other thing that Parametric will give you, if I move any part of this curve that's not within that span, it's not going to affect that object. I go back here to my motion path and turn Parametric off, and we'll set this value to something. Whoops. But it doesn't matter what. And I go in here and move this, you'll notice that my cube is now moving. And the reason for that is because this is like fractions across here, right? I think even in the path animation command, they call it fraction mode. And basically it just means that this is a percentage along this curve. So it's taking the whole value of the curve, breaking it into increments that are even. So this may right now be 37%, 0.37, yeah, 37%. Yeah. That if the curve gets longer, 37% is going to be here. If it gets shorter, 37% is going to be there. So you may right now want that. It's just something to keep in mind as you're creating your motion paths, but also as you're creating your objects or scripts, any scripts involving motion paths. Okay, so the other thing I like to do with scripts, just that was just side knowledge. All right, the other thing I want to do is turn this thing into a usable function. So right now it's just open code. It's all what we call global variables. It's not such a big deal in Python because you can change variables. In Mel, you can't, so it's kind of deadly. But I'm going to make a function out of this. So I'm going to say define, and I'll call it multi-mel path. That works for me, right? And when you define a function, any inputs you're going to have are going to go in the parens, and then this is going to be your scope again for Python. And I'm not going to go deep into Python, but I just want you to realize what's going on here. And again, I'm going to indent. So your scopes are denoted by the colon, but also by the indent. So this is the scoped area, for this whole thing, and then this is an inner scope, and then this is it's smaller inside scope. So anything that happens in here doesn't necessarily happen out here. Anything in here doesn't necessarily happen out here. I don't know if I've described that very well, but just so you know. So the thing that I do want to change is this hard-coded curve here, because I'd like to be able to select a curve and use it. So often what I do, I could do that two ways. I could say curve equal curve here, and then when I make my command, let's make a command out of it, nothing will happen. It's all it's doing is initializing and creating that command. And what's nice about Python in Maya is now I can use the command completion with something I've entered or initialized. So I'll select all these guys. I can now type in curve, curve 1, and that'll work. But you're not going to do that. That's not, So what I like to do is make it part of the selection process. So what I'm going to do is, I normally when I make my scripts, I say select everything that's going to be acted on, and it depends on what your selections are like. If you have a multiple selection, that's going to be the first one. If you have a singular selection, that's going to be the last one. Only because I feel like if you select the first item and then you start selecting other items, you might get lost. So I find it easier, select the multiples, then select the curve, good to go. But what I'm going to do is use another object-oriented part of Python called pop. So this is a list, right? So there's a command in, a command for list called pop, and I would say curve here equals that. And what that's going to do is you give it a value, or which array item to use. And what's cool about Python is I can actually do negative numbers. So if I do -1, what that actually does is it goes from the very end of the array or list and selects the first item going backwards. So if I said 2, it would go 2 back, etc., etc. So I'm going to say -1, and what that's going to do is if I select all these guys and then select this, it's going to make the curve my last selected object, right? And it's going to take the pop. What that does is it removes it from the selection and then returns whatever it was. So in this case, it's going to return the curve. So it's pretty much exactly what I want it to do. So I'm going to select all my cubes, select the curve, and run multi-row path. And it's going to put them right on there, like so. And everybody's happy, and I have a nice control, or a nice function that I can use later on to do different things. I might just call it there, because the only thing I would add to this, maybe I'll just do it. Fine, I'll just do it. So let's kill all this. So the last thing I'm going to do is I want to, instead of using the fraction mode, or what do you want to call it, I'm going to convert that to use parametric, non-parametric mode. And you know what, I have to run it to get the information. There we go. Let's just grab this, grab this. Sorry, I was thinking while typing. All right, let's look at our motion path. And it's parametric length attribute. Did it, oh wait, let me try that again. And undo, okay, fraction mode. See, there it is. It's fraction mode in the script, parametric length on the node, right? So bang false means true, right? Yeah, okay. So we're gonna put that here. Don't know why they'd write it that way and say false. Make sure I have the right parens in there. That's one of the things about script editing in the Maya script editor. Other than you could lose everything, it also doesn't show you. Usually you can highlight on most editors, you know, highlight a comma or a paren. It'll show you what the other paren is. But I think I got it. So let's try that real quick. Get rid of the cube. Get a bunch of cubes. Connect the mode path. All right. And I don't think I did the right thing. Did I initialize it? I can't remember. You know what? I'm going to undo that and do it again. Let's reinitialize our function. Run the command. Parametric length is on. Okay. So I want to make that, for some reason, true. Fraction mode, I guess, percentages. Yeah, you can see it. All right, and I did get an error, but I think I'm going to ignore it. Because I think it's, what it is I think it's overvalue, so it gets upset. But let's grab not these cubes. So cube 5, and look at its motion path. Okay, parametric length is off. Good, that's what we want. But the problem is it tried to set all these guys over 1, which it can't, because you can't have more than 1. So what I need to do is change what I'm inputting. I'm going to leave the numerator in there, it doesn't really matter, and I'll create a new value, call it n equals 0, and basically what I do is iterate. Well, what's a good, yeah, iter's fine, it's not the best. So I'll basically take 100%, and divide it by the number of objects that I have. So by cell. Yeah, that should do it. Although I think I want to do it by -1 because I want to make sure I have 0 and 1 in there. So the first one won't really count. So I grab that. I have an invalid syntax. Iter equals. Wow. Cool. Right now it's not doing anything. I'm going to change that value from I to n. And I'm going to say n equals n plus ITR. And for the fun of it, I'm going to say print ITR. Just so I can see it. All right. Kill that. Run this. Cool. Let's grab all our cubes here. Grab the curve. Cool. So our iterative is 0.2. And it should have put them all evenly spaced on my curve, which it did. So let's try a whole bunch of them. Kill that. Let's see if it can still work. Nice. So now it has evenly spaced these cubes all along that curve. All right. So things I haven't done that I would go in later to make sure we're correct is one, I was definitely name these motion paths. So often I would name it like the name of the object and then maybe motion path. I like to use Maya's original names for things, just so that way if I ever need to find them again, it's easy. I've seen some people change blend shapes to BS, motion paths to MP, things like that. I'm not a giant fan of that just because if you don't create it the right way and you don't name it that way, it won't be named that way. But Maya by default names everything, so we'll go with that. So let's just see what that looks like, because I think as long as I didn't screw up, that should work fine. Cool. And you know what? I'm going to get rid of that print because it's just going to slow us down. All right, so now if I grab this cube here, I can see P cube 6 motion path. So that's kind of nice. So often when I'm creating things like this, any node I create, I want to make sure that I name it. If it's something that needs to be iterative, I can use that I, and then everything would have, you know, numbers going up from there. All right, so I'll copy that, and we'll throw it into my NodeEditor for later. And this, my little multi-mill path here, I can actually just take that and throw it on my shelf. And now I have a shelf button that'll do that. So I don't even need the script editor open anymore. I can create a curve, create a bunch of objects, and run my script, and there we go. So I hope this has been helpful. If you have any questions, let me know. If you have questions about other things, let me know. I do like showing how to do things rather than just taking a concept or trying to teach people about it. So if you have something that you're interested in or whatever, let me know. I can try and make a tutorial that shows why that does what it does or how to do it. All right, so I hope this has been good. Thanks. And I just wanted to add that whenever you're dealing with these commands, you don't know what they are, the ones in blue. Most of these exist in Mel and in Python. So you can actually run a help command on that. So you want to do it from Mel, generally speaking. So you do like a help, let's say like ls, or let's say list relatives. That's always a great one, right? So I'm going to run that, and by highlighting it and using the alternate enter, it'll run that and not get rid of the information. If you use regular enter, it'll go away and not do anything. So you want to use the number pad enter. But this will give you all your flags that are going into that. And if you want to get more information, you can run help-doc list relatives, and that'll actually open up the help page with some examples. Sometimes the examples are good, sometimes they're really bad. But they're always helpful in some way. You can learn some things. And if you go up here to the right-hand corner, you can actually choose, oops, off screen. If you go up here to the right-hand corner, you can choose Python version. It'll actually show you it to you in Python and show you all the, they're not flags, but inputs. And they can show you some examples, which are almost the exact same examples, but in Python rather than in Mel. So if you're doing what I call Mel stealing or script stealing, and you see those scripts, you can kind of look up what they do. So what was that one we were looking at before? Was path animation, right? So I'll create a something and do a attached motion path. I get path animation is the command, right? So if I do a help on that, if I spell it correctly, it gives me back, you know, I can see that it's actually a mel command, and it gives me back all the information. I don't think it has anything there about skipping those nodes. Oh man, if I went through that whole thing and I could do it, that'd be really funny. And again, I can just write it out DLC. And the same thing is I can hit the Python version and it shows me all the Pythons in there. So yeah, that's it.